I was going to talk briefly about station maintenance because this is equally, if not more important to pay attention to because people just often neglect it, and it's a critical part of the network. So if you want to get data, you got to make sure your stations are working. That involves maintenance. So I just wanted to show this slide again because I think it's an important reminder of how much it costs to maintain stations. It can be expensive. At least $300 to visit each station once. Each, so that's $5,000 for us in this local network on average. Um, and if there's a way you can tell that a station is collecting data without having to visit it, that saves on the need for maintenance, at least to some degree. So you should probably check your station at least once a year, regardless of whether it's uh, reporting data to you or not. Um, but if you don't have it connected to the internet, you may want to check on that station 3 times a year or 4 times a year to make sure that it's working when you need it to be working. Um, so again, I'm going to go through each part of the station and what you need to maintain it. The tower is a bit of a tricky one because there's a lot of different setups, as I showed before. So you end up, the maintenance there is making sure it's standing upright. It's still secure, and that there's not a risk of it falling over, for instance. But it's basically doing its job. If there's any signs of corrosion or wear on the tower, uh, this might be especially problematic in coastal areas. That's something to keep track of. And you might have to replace equipment or fix stuff if anything arises. But it's hard to go into detail here because, again, it just really depends on your type of setup. Um, Antennas, are they pointing in the right direction? Are they damaged at all? Like, did something bend them or something? Um, are they still horizontal? So you want those elements to be horizontal. Sometimes it rotates so that they're vertical because things weren't tightened properly before. You want to check your coaxial cables as well. Sometimes animals like to chew on those cables, um, or sometimes just being in the hot sun for several years can cause the outer coating to crack, and that introduces that's an opportunity for water to get in and cause corrosion. Um, and then you have your receiver. Is it powered on? Is it collecting data? Is it, are the radio dongles that are attached to it working properly? Um, so again, that's also important. You'll be checking this anyways when you go to download the data. And if it's connected remotely, you should be able to tell if the receiver is working or not. Your power supply, especially important to check on and maintain if it's a solar setup. So sometimes the batteries wear out if they're being discharged too much over a long period of time, or if they've experienced really cold temperatures. Um, and then the cables can get chewed by rodents as well. And then data flow is something that you should be able to diagnose remotely. So that's something, though, you might want to check on periodically from your office is, are my stations checking in that are supposed to check in? So going through all the different tower types, I'm sort of recycling slides from another presentation. So again, there's a lot of tower types. Hard to say a particular issue, but oftentimes the issue will be where a mast gets bent because of wind. A guy line is snapped or loose, so that needs to be tightened, or an anchor is coming out, so that needs to be reset. Or perhaps the mast isn't fixed in place quite right, so it's rotating with the wind a little bit, so then your antenna directions are no longer the way you initially intended them to be. Um, those are generally the issues that we occur. and then a lot of corrosion problems that makes it hard to replace things. But yeah, so that's generally the towers are lower maintenance depending on the type. Tripods are generally high maintenance. Same thing with standalone towers, like these masts here. I guess I can't highlight stuff on the slide. Sorry about that. So I'll just keep moving on. Let's talk a little bit about antennas. The most common antenna type we have are these Yagi antennas. And there's a few different pieces to the Yagi antenna that are important to highlight. So you have your connectors you have the antenna boom there, which is in blue. That's sort of that central part. And then all your elements pop into the boom. The second element there is called the driven element. And that's the most critical part because that's where it's finely tuned to listen to the right radio frequency. It's also where your coax connector plugs in. So generally, you want to be the most careful with this piece. If you're storing it or transporting it, that's the part that needs to be most protected, and you don't really want to bend it. And then your coax cable attaches there, and you want to have that zip tied to your boom, so you're reducing the amount of strain on the parts of the antenna and to the coax cable. And finally you have your mounting plate. So the mounting plate is usually just a plate of metal with holes drilled into it, so that you can attach U-bolts to the mast and to the antenna. Now, to tell your antenna direction, you always look at where the coax cable plugs in, and that's going to be the back of the antenna. So in this illustration, the antenna is pointing to the right. Now, I have a little asterisk at the bottom there, just saying that for the purpose of this diagram, I have all the elements pointing vertically, but in reality, you're going to want to have those horizontal, and that just changes the actual geometry of it is important because that's the way that generally antennas are going to be on a bird. They're going to be more horizontal than vertical, so that you want your elements to be facing in that similar direction. So how do you check your antennas? Well, you use a compass to check the direction. It's good to have one of these, I guess, analog compasses with you at all times, but you can also use your phone, which I do all the time. It's really easy to do. The main thing you want to keep them track of is just don't be too close to the tower, because the metal of the tower is going to affect your compass. So stand like a good 20 meters away from the tower to check your antenna directions. And if there's any other big metal things, like a big sheet metal wall of another building, that's also could impact it. So just stay away from anything that's big metal stuff. And then record that, what the antenna direction is, the height of the antenna, or like what position is it the top antenna, is it the middle antenna or the bottom antenna? Because they're going to be stacked on top of each other, right, on the mast. And the port number for the antennas. So which USB port the actual and coax cable plugs into. The next one to check is cable condition. So sometimes what can happen is the cable gets damaged, maybe by a rodent chewing on it, or just by weather, or just force, because there's like something happened that caused the cable to get damaged in some way. You might have to fix the antenna, and that means that it's sometimes good to have a repair kit with you to repair the coax cables. It's not a very easy thing to do, though, and it's really good to have some instruction on how to do this ahead of time. It's also maybe only worth it if you have several stations and where this might be a recurring issue. We have many dozens in our network, so we tend to do this kind of thing, but people who have like 10 or so stations don't usually have this capacity to do it, so they just buy a new cable when they need it. but it is an option if you want to get into that, and there are videos on how to do it. And then antenna tuning. This one we want to be getting people to do more of, but we don't have. It's not very widely not widely spread how to do it. I guess people don't really know how to do it generally. But what I'm trying to say is, it's a good thing to be checking, make sure your antennas are listening to the correct frequency and are not getting too much noise. So we use a device called an antenna analyzer. This one here is the Nano VNA. So there's videos on how to use that as well. And there's a bit of a learning curve. It might feel a little technical, but it is. It's not too difficult to do. So we recommend people doing that. But again, if you only have a couple stations, it's fine if you don't do it. It's just something you might want to be doing once you have more stations and more antennas that you're working with. For the receiver, there's a few things to check. It depends on the type of receiver you have, but you're going to want to be able to connect to the receiver and download data. So for the type of receiver, you'll need different things. A sensor gnome, you're going to need basically no tools, but it's handy to have a spare SD card, and maybe an Ethernet cable and an SD card reader. And these, micro SD cards, because that's what the Raspberry Pi takes, is a micro SD card. To actually connect to your Raspberry Pi, all you need is Wi-Fi. So you can use your phone or your laptop. But if there's any issues with that, you can also use an Ethernet cable to do that. Same thing. If you can't connect to it for whatever reason, you might have to download the data manually by taking the SD card out of the receiver or out of the Raspberry Pi and plugging it into your laptop. And it's good to have a spare micro SD card so that you can put the software on that spare SD card and swap it out for the one that's not working. And that should resolve your problem. Remember, whenever you're touching an SD card, you always make sure your sensor gnome is powered off. You don't want to be pulling that out while it's still powered on. You can corrupt the whole thing and lose all your data. Just an important detail there. For your sensor station, you are going to do slightly different things. They don't have SD cards, they have internal storage. So you're going to have to get access to that either via Ethernet cable or using a USB stick. So by far the easiest way is to use a USB stick, and then there's like an on-board, there's a little screen on the board and some buttons you can use to actually direct it to download data. Instructions on how to do that are in the sensor station guide. I'm not going to go through it step by step here. It's not worth it. However, it's a really good idea to have an Ethernet cable and a USB to Ethernet adapter, because sometimes there's issues that you can't diagnose using the thumb drive alone. Sometimes, and the only way to actually get into the sensor station and view its web interface is to use this inner Ethernet cable and USB to Ethernet adapter. The USB to Ethernet adapter is important because there's no Ethernet plug on the sensor station. It's also possibly needed for your laptop. A lot of laptops these days don't have Ethernet ports. So you might need two of them. Just note there, double check that. And then for other stuff you might need, like bits and bobs, there's probably nothing else that you really need for the sensor station. It's just those couple pieces there for the tools. For an S-Direct receiver, you just plug it into it with your laptop using a USB cable. It's pretty straightforward. And again, instructions on how to download data are in Lowtech's user guide. So we're not going to go through that here. It depends on the model, and there's too many details there that we're not going to get into. Probably won't be relevant to you anyways. Okay, for power, there are a few more things that you can do here that aren't on this slide, but to start off, if you're on solar, you're going to want a multimeter. A multimeter tells you the voltage of things as well as the resistance of things or the continuity of cable. So what I mean by that is it can tell you if there's a two different points are connected to each other electrically. And that's really important if you're suspecting there's a break in a wire that you can't see or something like that is a connection problem. That really helps diagnose those problems quickly. Um, you'll also want this multimeter to tell the voltage of your battery, of your solar panel, and potentially to see if there's a voltage arriving at your sensor node, if that's the problem. The use of a voltmeter is relatively easy. A lot of people have used them in the past. A lot of people know how to use them, so getting instruction on it isn't too difficult. But knowing, you know, step by step how to go through everything and diagnose problems is a little tricky. Takes some experience. So the other option is to use, if you're on the AC, you want to check, and you're having power outages, it's good to have stuff that helps you check AC outlets to see if they're working. And then a USB tester helps you tell if the USB adapter that you have is working. So these are basically, I think, pretty standard household items. There's also like a plug. Yeah, plug testers work well, but there's also these little wires, these little sticks that tell you if there's wires in the wall. So you're drilling a hole in a wall. Those little things are helpful for that. Just to, you don't want to drill through an AC cable. But yeah, so if you're ever fixing a power issue, you will need some extra equipment like wire cutters, extra wire, and wire strippers, and potentially some connectors. So these are all bits and bobs that you would already have installed with the station. You also will want some fuses. There's usually a fuse on your battery, so it's good to check that to make sure that it's not blown. Zip ties are always handy to have because they're used to attach the coax cable to the mast and all the way down, but also just used to organize cables and keep things tidy. Electrical tape, we use colored electrical tape to color code the antenna cables. That's a really handy feature. And then silicone sealant, if there's any holes that show up in your boxes that you're storing battery in, or for the sensor dome that you don't want anymore, silicone sealant is an easy fix. All right, so that's it.